This is the brief on point source diffusion. So we're diving into the stationary solution for diffusion. We're going to look at what happens when you have a substance coming from a constant single point, like a tiny steady leak. This shows us the fundamental rules for how stuff spreads out and finds a perfect balance in space. Okay, so let's get into the key takeaways. First, the whole system is governed by two related inverse power laws. One describes the concentration of the substance, and the other describes its flow away from that source. Second, the concentration potential. This follows what's called the inverse distance law. That's 1 over r. It just means the farther away you get, the less concentrated the substance is. This creates a really sharp peak right at the source, and that's what actually drives the substance to flow outwards. And finally, you've got the current density. That's the flow itself. It follows the inverse square law, so 1 over r squared. And this faster drop-off is absolutely crucial because it ensures the total amount of stuff flowing out stays constant. You see, as the substance spreads, the surface area it covers grows as r squared. So the flow has to decrease by 1 over r squared to keep everything perfectly balanced. So that combination of the inverse distance potential and the inverse square flux, that's the elegant steady-state mechanism for any constant point source.